All right, this is part 4, and we're going to talk about pulse parameters. We could probably spend an hour talking about this, but we're not gonna, because you don't want to hear all of that. But it can get that complicated. But I'm going to try to boil it down as much as possible to let you know the basics on what you need to know. And if you want to dig further, you'll really just have to start experimenting yourself, and that's really the only way to figure out exactly pulse parameters that are most beneficial for your application.
Aside from the main amperage setting, which by the way you're going to have to set about twice what you think you normally would need. So if you normally would need 50, you're going to have to set the main amperage on more than 100, because you're getting an average of a low and a high pulse. So remember that. But other than that, you got these 4 knobs. You got a pulse off switch that you can bypass it with, and you got a low and a high speed pulse. And a low speed pulse on this Everlast Powertig 250 EX, it goes from 0.2 to 20 pulses a second, and if you switch it on high, it goes from 20 to 500. And moving over one knob, you've got pulse amps, and pulse amps ratio actually, and that is a ratio of the low and the high. So it is the percentage of the background current is of the high speed. So if you've got it set on 100 amps and you set it at 5%, it drops all the way back to 5 amps and it spikes up to 100 amps. And if you've got it set at 95%, it only drops down to 95% and 95 amps. So that's not going to be much of a difference, and just barely dropping down, not going to be much of a pulse effect. Pulse time on is the percentage of time that the current stays at the high side of the pulse. So the higher you have it set, it's a very similar effect as the pulse amps ratio. Higher you have it set, the hotter the arc is going to be. The lower you have it set, the more it's going to flutter, and the more spread there is, and it's going to have a lot different effect on heat input. All right, this bead was set at about 1 pulse a second, and gradually, well, later on we're going to increase it, but you can see it spreads out the ripples, controls heat, and it all depends on travel speed on how far the ripples are spread apart. But I had it set at this particular travel speed to space the ripples quite a bit. So here we've got 1 pulse a second, gradually cranking it up a little bit. I know you can't see the puddle very well, but it's just to show you the difference in the pulse rate. And then we're going to go all the way up to about 20 pulses a second, and then show you the effect on the bead. So start off, the ripples are kind of widely spaced, and as we cranked up the pulse rate, or pulses per second, the ripples get tighter. And actually, if we put a ruler on this bead, you could see it shrink a little bit by about 1/16 of an inch by the time we got down to 20 pulses a second there at the very, very end. So the higher you go, the more it constricts the arc and the narrower the bead to an extent. And again, this is on automated travel speed, so that's why we're seeing the distinct difference here. The bead inboard, the one that's silver, don't be fooled by why it's silver. It's just set at 20 pulses a second, and the reason it's silver is because it was much more of a heat sink. It cooled much quicker being not on an edge like that, so the argon shielded it better. Here's 2 beads, one at 20 pulses a second and one at 100 pulses a second. All other things staying the same. The narrower one is the 100 pulses a second. Again, we've got this thing set up on a welding lathe, so we maintained arc length and maintained travel speed just to show you. Otherwise, there'd be no way we could alter it any way we want if it was manual and we had a foot pedal on it, and would compensate, and you wouldn't see any difference. Another wrinkle is when you start feeding wire. See, I had this pulsing at 20 pulses a second, but I was feeding wire at roughly once a second, so I've got my ripples at 1 a second, regardless of my pulse. So wire feed has a little bit of a pulse effect. I turned the piece over on its end, and the narrow bead on the left, you can see, was at 5% on the pulse amps ratio. I kept everything else the same. All I did was increase the pulse amps ratio up to about 50, and you can see the bead get twice as wide. So, you know, it's just one thing affects another, and it's like squeezing a balloon one place, having it pop out in the other, as far as the pulse amps ratio and the pulse time on go. But you're going to have to just get this thing, and I'll tell you what, the best way to get started off and with it is have everything, set it on high, and set everything at high noon. That's going to give you about 100 pulses a second. It's going to give you about 50% ratio and a 50% on time, and you will see a difference, and then go from there. That's the best advice I can give you on experimenting with pulse parameters. Again, you can see all these beads look good. They're all good. And if I had a foot pedal hooked in, controlling the amperage, you might not see much difference in anything, because I would have been trying to compensate for everything and make the bead width what I wanted the bead width to be. But again, welding close to an edge using that pulse is beneficial. It does have an effect on heat input. It's not night and day, but sometimes all you're looking for is just a little difference, and pulse will do it.
So let's boil it down in this way. All right, let's talk about it as if there are two modes of pulse. Okay, slow speed pulse and high speed pulse. And when I say slow speed pulse, that's generally in about the 1 pulse per second range, maybe 2, maybe a little bit less, but in that range. That is not so annoying to look at. It flashes, it backs off, it flashes, it backs off. It gives you time to add the filler during the hot part, time to move ahead during the slow part. It does keep heat from building up. Yes, you can do that with a foot pedal, but you can't do it as predictably and precise as if you have a pulsar capability on your machine. Okay, so high speed pulse for me is like 30 and above, and that big gap in between like maybe in between 2 pulses a second and 30, that's no man's land to me. I hate it. There are certain ranges of pulse that's been some study that can even send you into some kind of epileptic seizure or something like that. All I know is it's annoying as crap. Okay, when you got 10 pulses a second, you can't. It's very hard to focus on the bead. Imagine doing that for 8 hours, trying to focus on 10 pulses a second and feed your wire. I'm gonna be saying welcome to Walmart before I have to do that. High speed pulse, 30 pulses and above. Actually, I prefer to weld higher than 30, even closer to 40, because you get a benefit. 30 to 40 pulses and higher flutters the puddle. It agitates the puddle and it focuses the arc cone, and it does make a difference. It makes a difference, especially in an automated application, and especially when you're welding close to an edge. If you imagine you're welding a lap joint and you've only got a 1/16 of metal hanging over that lap joint, okay, that heat's going to want to wick out and fingernail curl that corner off. I'm talking about thin stuff here, say 18 gauge metal, 18 gauge steel or stainless steel. If you're welding near an edge, you know what I'm talking about. That puddle wants to try to wick out, run out, and melt that edge off, because there's no heat conductivity out on the edge, and it wants to heat up there. That's where the heat's going. With pulse, it makes it stick better. Does that make any sense? I don't know why, but it makes it stick. It very much prevents it from floating out and wandering the puddle. It makes that puddle stick where you put it. And you can whistle Dixie while you're welding instead of be so uptight and really. Without pulse, yeah, you can do it, but you really gotta pay attention. Really gotta play that pedal. With pulse, you can kind of daydream a little bit, and that's really the difference. I mean, it's not like you can't do it either way, but sometimes that is the only, and so it's kind of worthwhile.